Hi, my name is Elizabeth Hutchens, and this is my project on flooding in Pakistan and using remote sensing to examine Pakistan's 2022 flooding and change detection. To start, I'm going to talk about the overview of my presentation. I will be going over the introduction, the study area chosen, the data and software used, the workflow I tailored the project to, the results, and ending with the synthesis. Floods are some of the most severe and devastating natural hazards, threatening lives, properties, and living environments. Rapid delineation of the spatial extent of flooding is essential for dynamically monitoring flood evolutions and corresponding emergency strategies. Pakistan's 2022 monsoon season produced significant rainfall, devastating floods and landslides affecting millions. The recent flooding has been characterized as Pakistan's worst. This final project will investigate change detection during Pakistan's floods of 2022. Satellite remote sensing is increasingly essential for flood mapping. Optical remote sensing has been used for dynamic flood monitoring based on the low reflectance of water in the infrared bands and high reflectance in the blue-green bands. In practice, however, flood events often happen in bad weather characterized by heavy clouds and intense rainfall, which hampers the effective use of optical imagery instruments because of the lack of cloud-free, high-quality images. Optical sensors often cannot detect standing water under vegetation in densely vegetated areas. Using remote sensing to examine Pakistan's 2022 flooding to conduct change detection. Pakistan is located northeast of the South Asian subcontinent, bordering the Arabian Sea in the south, India in the east, China in the northeast, and Afghanistan in the northwest. The territory of Pakistan covers an area of 880 square kilometers. Some 60% of the country is mountainous and hilly. There are extensive deserts in the south, coastal regions, with plateau grasslands extending to the north. The Himalayas and the Hindu Kush, three of the most famous mountain ranges in the world, coverage in the northwest of Pakistan and feed numerous glaciers and glaciers lakes. Pakistan lies in the temperate zone and has a subtropical climate characterized by high temperatures and scarce precipitation. The annual mean temperature is 27 degrees Celsius. On average, the mountainous areas of Pakistan receive 200 to 900 millimeters of precipitation annually, and the rest of the country mostly covered by plains receives 180 to 460 milliliters. During the course of my final project, I have narrowed down the study area significantly. I picked Sai Province focusing on Lakarna because water has yet to reside and may remain for several months. According to the Provincial Disaster Management Authority of Sai, over 89,000 people remain displaced in the province as of January 2nd, 2023, which is down from 6.5 million early September, and still require assistance and aid. Lakarna is a city located in the Sai province of Pakistan. It is the 15th largest city in Pakistan by population. It is home to the Indus Valley Civilization. The historical Indus River flows in the east and south of the city. The city is located within Lakarna districts and the population is 490,000 as of 2017. Data and software used. The data used was downloaded from Earth Explorer. With the original intent of the project, I wanted to focus on 3 flood seasons. However, due to processing time and narrowing down my study area, I focused on 2 data sets that were downloaded from Earth Explorer. So I downloaded Landsat 9 for the flood season of 2022. And then I downloaded Landsat 8 for 2021 to do a side-by-side comparison of the water variation within the area. Each spatial resolution for this data is 30 meters. The software used was ArcGIS Pro 3.1, and within it, I used several different tools. I used the composite bands, the ISO clusters, the reclassify, raster to polygon, dissolve, and calculate geometry. I will go into further detail of these tools in the next slide of my workflow. As stated in the previous slide, I downloaded all the data from Earth Explorer and used ArcGIS Pro toolsets. I used composite bands to perform composite bands on both images and look at different band combinations to assess areas of increased water for the 2022 flood occurrence and compared to the previous year. I then performed an ISO cluster to break up the raster into usable land cover areas to further aid the analysis process. I then reclassified the raster where water pixels were given a value of 1 and all other pixels are assigned a value of 0. I then turned that raster into a polygon and dissolved and combined the various polygons. Calculate the total amount of water change in each image. As we can see, there is a drastic change from 2021 to 2022 variations. In 2021, we see that the area is 3,700 square kilometers, and in 2022, we see an increase to 12,700 square kilometers in variations between the flood area and the previous year. Comparison between August 2021 left and August 2022 right. In the previous slide, Figure 1 depicts water variation from datasets obtaining using Landsat 8 on 2021 of August, and Figure 2 depicts water variation from dataset obtained using Landsat 9 of 2022 of August. The onset of the 2022 monsoon brought heavy rains which caused damage, flash floods, and landslides in several provinces from mid-June. Higher temperatures also resulted in glacial lake outburst floods. For example, in the Lasper Valley province on the 3rd of July 2022, and in the Hansa district province on the 2nd of July 2022, heavy flooding along the Indus River in Pakistan. Heavy monsoon rainfall continued throughout July and August with dramatic effects. Rainfall during monsoon season peaked in August, which has brought remarkable downpours of flooding, which was the cause of the flooding in the study area is inside province city Lakana. Figure 3 depicts the values of the water extent changes over the time based on Landsat 9 and based off Landsat 8. Describe how results address the original problem statement and objective. The results address the original statement and objective by using remote sensing to examine Pakistan's 2022 flood to conduct change detection and compare that to August 2021 of the previous year. What worked well, what did not work well, what problems were encountered, and how were they solved. During the gathering data and performing processes such as composite bands and ISO clusters, the system would freeze and shut down, causing the process to fail. So I narrowed down the study area to a much smaller size to solve this issue. The original idea of comparing different flood seasons that Pakistan experienced and comparing the variations was not a success due to the amount of data and processing time. Along with the system freezing and/or shutting down, a classmate suggested I focus on one flood season and compare the variation of that of a previous year. By narrowing down the study area and only focusing on one season, the process went smoother and less processing time was needed. What would you do differently if you were to start this project again from scratch? If I were to start this process over, I will look further into using Sentinel data. During my research conducting this type of product, I noted that Sentinel data was far better to work with as it is designed for this type of product. Sentinel data helps gather water pixels that may be masked by vegetation. Unfortunately, the web application requested to download a Sentinel data gave me a no product found error. I searched other locations like Germany, which the website gave in their how-to guide, and received the same error. I contacted them and was unsuccessful with gathering the Sentinel data. So if I had to start this project over from scratch, I would definitely go into using Sentinel data. What was the single most significant thing you learned from this project? The most significant thing I learned from this project is the many ways to examine flood analysis and the importance of the results. I would definitely use Sentinel data as this is one of the single most significant things that I learned during the flood analysis is that it is useful and far better data set to work with. Thank you for tuning into my final project. I hope you enjoyed. Looking forward to any feedback. Thank you and have a great day.